Good day. Today we're going to cover Gay-Lussac's law. Gay-Lussac's law deals with pressure and temperature, so we're holding the number of moles and Kelvin constant. And one thing I haven't mentioned in the other videos, how do we hold moles constant? Well, you capture and trap a gas. Like when you blow up a balloon, you're putting moles in, but once you tie that balloon, you have a certain number of molecules in there. And so that's how we hold moles constant. If you have a rigid container, you're holding volume constant. A rigid container would be like what you see on a gas grill, a gas cylinder, a propane tank out in the yard. Those would all be containers that can't change size, and so fixed volume. Well, Gay-Lussac's law says if the number of moles and volume is held constant, the pressure of the gas is directly proportional to, again, Kelvin temperature. And so if it's directly proportional, that means that P1 all over T1 is equal to P2 all over T2. A graph of a direct proportion, of course, is a straight line. So here you can see the pressure is about 300, almost 300 here at 100. I double the pressure and I'm almost to 600 here. And so you can see that that does work for the direct proportion. How does popcorn pop? Well, popcorn uses Gay-Lussac's law. It has a fixed volume. It's got that nice little hard shell, and that nice little hard shell traps in water. Well, when you heat it, the water changes to water vapor and it explodes the shell. And so that's how popcorn pops. So what do you think would happen if you poke little tiny holes in the kernels? Well, what would happen is none of it would pop. And that's why you have some unpopped pop, is the hull is damaged or there wasn't that much moisture in the kernel, one of the two. Gay-Lussac's law, also why you see mishaps on the road, especially with semi-trucks that carry a heavy load and they have a lot of friction with the road. They have a lot of blowouts. And so that pressure increases beyond the capacity of the tire to expand. We'll define a term for you right now. That term is sublimation. The sublimation is the process of a solid changing directly to a gas without going through the liquid stage. And this picture here is of dry ice, which is carbon dioxide solid. You can barely see some solid right in there. And they used to use it in the movies as the fog making in some of the scary movies. They have a different mechanism to do that now because the actors complained about how cold it got. But that used to be one of the methods. Here is another video of sublimation. And what we've got here is we've got some of this this blackish color iodine right here. And we're going to heat it and see what happens. And we could expand this so you could see it a little bit better. And so what they actually did there is they actually added glycerin to it instead of heating it. And the glycerin makes it vaporize. And so you can see that it turns into this purple vapor. It's kind of a neat reaction. I would do it for you if we were at school, but doggone, we're not. So that's that.